Hi, today we're going to learn about electric charge. We're going to learn what electric charges are, the electromagnetic force, and conclude with a little bit of history. But before we dive into this topic, I want you to think about this. What do lightning, a candle flame, and a light bulb all have in common? Well, what they all have in common is electric charges and the electromagnetic force. Lightning is caused by static discharge between the ground and clouds. In order to see using a light bulb, we require electric charges to move through a circuit. To even see the flame of a candle, the flame is ionized gas. And that ionized gas means the gas was stripped of charges. So, what are electric charges? Well, we can think of electric charges as particles that interact with other electric charges through a fundamental force of nature called the electromagnetic force. Now, the electromagnetic force is one of the fundamental interactions, and without it, you and I wouldn't exist. The electromagnetic force is the fundamental interaction that binds electrons to nuclei to form atoms and binds atoms together in molecules and solids. Now, there's a number of different, well, really 4 different fundamental forces in nature. So you've probably know about the one that you could most readily interact with, at least in your experience. We've all heard about gravity. What goes up must go down. You know, an apple drops from a tree and is pulled to the ground by gravity. The force that this class is expressly focused on is the electromagnetic force. So the electromagnetic force, let's look at parts of that word. Electromagnetic. So there's really 2 sides of this force that physicists prior to the late 1800s thought were separate. There's the electric force and there's magnetic forces. You've experienced electric forces anytime you've walked across a carpet and then touched a metal doorknob and shocked yourself. You've probably played with magnets, so you have some experience with magnetic forces. Well, a guy by the name of Maxwell in the late 1800s realized that those 2 seemingly different forces are really part of the same electromagnetic force. Now, here's the thing with the electromagnetic force. It's 10,000 times more powerful than the weak force. That's huge. So that means the electromagnetic force is about 100,000 trillion times more powerful than gravity. Now you might be wondering, well, Mel, if it's so powerful, why don't I see this electromagnetic force in my everyday life? Well, you do. You probably just didn't know it was the electromagnetic force. Right now, I'm sitting in a chair as I'm conducting this lecture to you. Gravity is pulling me down into the chair, but what keeps me from moving through the chair, what stops gravity dead in its tracks? The electromagnetic force. It's powerful, it's everywhere, and really, most forces that you interact with on a day-to-day level, it's part of the electromagnetic force. You just didn't realize it. We're going to explore that more. This course is entirely focused on exploring electromagnetism. In the first part of this course, we're going to focus on the electric side of electromagnetism. And then later on, we'll focus on the magnetic side, concluding with tying them together. So the electromagnetic force has an infinite range. Now, it acts on both positive and negative electric charges. We're going to learn about those. It's very strong, about 10 to the 41 times stronger than the gravitational force, which remember, That means it's 100,000 trillion times more powerful than gravity. And the electromagnetic force is responsible for the chemical properties of atoms and molecules, and most of the everyday forces we're familiar with. So that seems pretty important, doesn't it? Without the electric forces, life as we know it wouldn't exist. The sun wouldn't shine. The sky wouldn't be blue and rainbows wouldn't appear. Chemical reactions that are going on right now in the cells of your body are based on the electric forces between the interacting electrons and atoms. The fact that you're seeing and listening to this lecture, it's because of electrical signals in your brain, between the neurons in your brain and up and down your spine and in your nervous system. Those different electrical signals depend on electromagnetism. Even your ability to touch, your ability to feel if something is soft or to smell a flower relies on electromagnetism. So this seems like some pretty important stuff. So we first became aware of these electric forces about 2,400, 2,600 years ago. It was known to the ancient Greeks as long ago as 600 BC that amber, rubbed with wool, acquired the property of attracting various light objects such as hair. They also noted that if they rubbed the amber for long enough, they could even get a spark to jump. In describing this property today, we say that amber is electrically charged. This term is derived from the Greek electron, meaning amber.